Good morning and Assalamu alaikum. Today we will start 1.2, the modern periodic table. In the modern periodic table, all the elements are arranged in ascending order of their atomic numbers, and following are the essential features of the periodic table. Groups and periods. Elements with similar properties are placed in vertical columns called groups. There are 8 groups, which are usually numbered by Roman numerals 1 to 8. Each group is divided into two subgroups designated as A and B subgroups. The subgroups containing the representative or normal elements are labeled as A subgroups, whereas B subgroup contain less typical elements called transition elements and are arranged in the center of the periodic table. The horizontal rows of the periodic table are called periods. The essential features of the period are as follows. There are 7 periods in the periodic table, numbered by Arabic numerals 1 to 7. The period 1 contains only two elements, hydrogen and helium. The period 2 and 3 contain 8 elements each and are called short periods. All the elements in these periods are representative elements and belong to a subgroup. In these periods, every eighth element resembles in properties with the first element, as lithium and beryllium in the second period resemble in most of their properties with sodium and magnesium of the third period respectively. Similarly, boron and aluminium both show oxidation state of +3. Fluorine in the second period has closest resemblance with chlorine of the third period. This is the modern periodic table, as you can see, arranged in the form of atomic numbers, ascending form. The periods of 4 and 5 are called long periods. Each long period consists of 18 elements. Out of these, 8 are representative elements belonging to A subgroup similar to second and third periods, whereas the other 10 elements placed in the center of the table belong to B subgroups and are known as transition elements. In these periods, the repetition of properties among the elements occur after 18 elements. As after potassium having atomic number 19, the next element with similar properties is rubidium. The period 6 is also called a long period, which contains 32 elements. In this period, there are 8 representative elements, 10 transition elements, and a new set of 14 elements called the lanthanides, as they start after lanthanide. Lanthanides have remarkably similar properties and are usually shown separately at the bottom of the periodic table. The period 7 is incomplete so far. It contains only two normal elements, francium and radium, 10 transition elements and 14 inner transition elements. The inner transition elements of this period are called actinides, as they follow actinide. The actinides are also shown at the bottom of the periodic table under the lanthanides. Due to their scarcity, the inner transition elements are called rare earth metals. Some more families that belong to the periodic table. While studying about periods, you have noticed that certain rows of elements with similar properties have assigned common names such as transition elements, lanthanides, actinides, or rare earth elements. Similarly, due to their peculiar characteristics, some typical elements belonging to subgroups A have also been assigned family names. For example, elements of group 1A are called alkali metals because of their property to form strong alkalis with water. Uh, 2Na plus 2H2O gives us 2NaOH plus H2. And similarly, due to the presence in Earth's crust and alkaline character, the elements of group 2A are known as alkaline earth metals. Another important family in this periodic table is halogen family. The name halogens is given to the elements of group 7A due to their salt-forming properties. As the gases of group 8A are least reactive, they are called noble gases. These family names are useful for quick recognition of an element in the periodic table. 3. Blocks in the periodic table. Elements in the periodic table can also be classified into four blocks. This classification is based upon the valence orbital of the element involved in the chemical bonding. According to this classification, elements of 1a and 2a subgroups are called s block elements because their valence electrons are available in s orbital. Elements of 3a to 8a subgroups except helium are known as p block elements as their valence electrons are present in p orbital. Similarly, in transition elements, electrons in the d orbital are responsible for their valency, hence they are called d block elements, and for lanthanides and actinides, valence electrons are present in f orbital, hence these elements are called f block elements. The classification is quite useful in understanding the chemistry of elements and predicting their properties, especially the concept of valency or oxidation state, metals, nonmetals, and metalloids. Another basis for classifying the elements in the periodic table is their metallic character. Generally, the elements on the left-hand side, in the center, and at the bottom of the periodic table are metals, while the nonmetals are in the upper right corner of the table. Some elements, especially lower members of the group 3a, 4a, and 5a, as shown in the table 1.1, have properties of both metals as well as nonmetals. These elements are called semimetals or metalloids in the periodic table. Elements of group 4a to 8a. At the top right hand corner above the stepped line are nonmetals. The elements just under the steps such as silicon, acetine and technetium are metalloids. All the remaining elements except hydrogen are metals. Allah Hafiz.